float assembly. A common ice chute is used. Instead of a thermostat, a mechanical bin switch will shut the ice flaker off when the bin and chute are full. The side panels are removed for servicing the unit by removing the knurled head thumb screws. No tools are necessary. The two evaporators and the float assembly are located in the lower section. The two ice chutes from the evaporators will dump the ice flakes into a main vertical chute. The float assembly is mounted on the front of the main chute at the height necessary to maintain proper water levels in both evaporators. A large evaporator drain pan is used to catch any condensate, leakage, or drippage before it can reach the ice storage area. The water inlet drain connections and the electrical junction box are found on the back. This view of the bottom also shows the outlet of the main ice chute leading to the bin area. When the bin is full, the ice will build up inside this vertical chute.
Okay, so you're looking at the bottom of this. This is where both of the augers are dumping ice down the middle. Okay? When the bin fills up, it starts backing up inside that chute, right? And when it starts backing up inside that chute, there's a little flapper. And it makes that flapper come up and terminate Icemaker.
When the ice has filled the chute, the harvesting of ice will continue until it presses against a lever in the cover. This lever will actuate a micro switch and shut the ice flaker off. Next, we will remove the cover and investigate the lever switch. Remove the knurled head thumb screws and lift the cover off the chute. The V-shaped lever can be seen projecting below the cover. It is hinged at one end. The other end is engaging the switch operating rod. To remove the lever, unscrew the two hinge screws. The slot in the switch end of the lever will slide onto the switch operating rod between the two horseshoe clips. The switch operating rod is equipped with a disc which will push up the lower switch plunger when the lever and rod are raised. In this position, the switch plunger extends out of the top of the switch housing. The ice flaker is shut off. When ice has been removed or has melted, the lever is allowed to drop back to its lower position. The switch operating rod is retracted and the horseshoe clip at the top will pull down on the hinged leaf.
Okay, so there's no bin thermostat in this. So if everything stopped, it could be that switch right there, because when this thing comes up, when it fills the ice, it comes up and it hits a switch in here, and that switch will stop everything. So, you know, in this particular case, there's no bin thermostat, so if everything is stopped and the on-off switch is okay, you're going to want to go right there and bypass from here to here with a jumper. Okay? And if it works, you know that switch is bad. It's like any other switch. Just jump across it. If it works, you got a bad switch.
And that thing's working like as ice builds up and just slowly pushing it up. It just seems weird. It just seems like it would just sit there and just get frozen into its spot. It doesn't seem like it will, but it does.
The weight of the lever will pull the switch plunger down and restart the ice-making operation. The accumulator on the CHF-14 is located behind the ice chute. The insulation has been removed to show its size and shape. The suction line from each evaporator enters the lower end. The suction line to the compressor is attached to the accumulator outlet at the top. The condensing unit is mounted in the upper section of the stack-on flaker framework. The compressor is a 1.5 horsepower capacity and uses a 240-volt permanent split capacitor motor. This unit is equipped with both high and low side service valves and a dryer. There are several additional electrical components in the terminal box of the CHF-14. Two auger motors make two start relays and overloads necessary. There are two power relays, as both 120 and 240 volts are being controlled. Power relay number 1 is identical to the one used on single evaporator models and controls the 120-volt circuits. Power relay number 2 is the switching mechanism for the 240 volts to the condensing unit. The compressor starting relay, capacitors, and the on-off switch are also easily serviced in this terminal box location. The refrigeration components of this double evaporator model operate in the same manner as the single evaporator self-contained flakers. The size of components, the extra evaporator, and the high-side service valve make up the difference. This wiring diagram of the CHF-14 has the on-off switch open. 240 volts are applied to the two outside wires. The middle one is neutral for the 120-volt circuits. The chassis ground connection is made by attaching a separate ground wire from the green screw on the junction box to the nearest cold water pipe.
Okay, you're going to see a lot of this where you've got 240 coming in, but they're running the control circuit on 110. Okay, the way they do that is, you see the neutral right here? Okay, in other words, 240 coming in, here to here, 240, one leg, and the neutral, that's 110.
In that area.
Yeah. So, you know, it's kind of confusing when you first start out there because you're like, why is this 110? Why is this 240? But if you divided this up into two schematics, one schematic for 110, one schematic for 240, it would be easier for you to understand. So right now, you're just going to have to believe it. It's just like when they have, like, you know those big display cases? Okay? They're 240. But the light bulbs inside are 110. How do they get 110 out of 240? One leg and a neutral.
Now, when these are operating, both evaporators are going to be operating at all times. It doesn't shut off one evaporator.
It has two augers, so it has two auger overloads, power overloads, and two solenoids.
Follow local electrical codes. This diagram is more complex than the diagrams discussed earlier. There are two power relays and two auger motors with their starting and overload components. Before we close the switch and energize the circuits, notice that power relay number 1 has one normally closed contact and one normally open. Power relay number 2 contacts are both normally open. As the switch is closed, the circuit is completed through relay number 1 and the bin switch to power relay number 2 to neutral. This 120-volt circuit energizes the coil in relay number 2, closing its contacts, which supply not only 120 volts to the auger motors, but 240 volts to the compressor as well. This is the freezing cycle, which will run continuously until the bin is full. When the bin is full and the ice has filled the ice chute, the bin switch will open and shut off all circuits. When ice has been removed or melted, the switch will close and restart the freezing operation. If either auger motor circuit becomes overloaded so that it is drawing more than 3 5/10 amperes, the power relay overload switch for that motor will warp closed. A 120-volt circuit is completed to the power relay number 1 coil. This breaks the circuit to the power relay number 2 coil and consequently all other circuits in the system. Power relay number 1 coil will remain energized by a self-sustaining circuit until the on-off switch is opened momentarily and closed again. The cause of the overloading should be checked out. It may be due to a low charge of refrigerant, low water level, mineral deposits in the evaporator, or a worn auger bearing. To be sure we understand the dual evaporator ice flaker operation, it is time to review this section.
Please stand by while the recording is turned over.
No, I don't think so.
That said, if the one overload, number 2 overloads, it's gonna touch the whole system. Previous.
Yeah, if either one of those augers,
Until 3. A leaky shaft seal in the cover may then be easily replaced. The shaft and bearing is also replaceable if scored or worn. A repair kit has...
Okay, now this is how you're going to rebuild that gear assembly if it starts leaking oil out of that weep hole.
been set up. To remove the gear from the shaft, remove the cover, invert the shaft assembly, grasp the gear, and pound the other end of the shaft on the piece of wood until free. Reassemble it in the same manner. The shaft and gear hub are machined to close tolerances for a snug fit. A woodruff key is used to mate the two parts. 2 service kits have been set up for servicing the auger motor gear case. One is a seal and gasket kit, part number 831572, to be used if an oil leak is the problem. It will contain several gaskets, which also serve as end play adjustment.
Are we there? Go up one more. No, it looks like, okay. Yeah, go ahead, go up one, go up another one. Okay, this is how you get the whole thing apart. You take a piece of wood and you slam it on the piece of wood until it comes out. Okay?
That shaft has a key, right?
Yeah, there's a key in there.
Okay.
Yeah, there's a key in there. Go ahead, go up one more. Okay, that's the key. And it fits right in there, and it fits right there. If you ever see something like that, don't forget to put it in. It's, yeah, this little key goes right there, and it fits right in there. Go up one more. Okay, here's the little kit they were talking about. You'll buy the cover gasket, and you'll buy the shaft seal. Okay? Go up one more. I think that's where we are. Okay. There's the shaft seal, cover for the cover.
The technician will, by trial and error, find the number of gaskets needed on each job to eliminate binding or to prevent excessive shaft end play. In the event the shaft is scored, another kit, part number 831574, is available containing the gaskets, seal, and a new shaft and bearing assembly. The defective seal is removed by punching it out. The new seal can be driven squarely into the cover recess by using a block of wood as illustrated. The lip of the seal must face inward toward the oil.
Okay, if you ever have to put a seal in, the most important part is to get it straight when you start putting it in. You guys don't have a press. You don't have a press. You're going to do it with a piece of wood and a hammer. So you start it off, tap it with the wood, make sure that it's nice and it's starting nice and even, then just beat the hell out of it till it goes in.
This concludes the Whirlpool Vertical Evaporator section of the Icemaker program. Now is the time to ask any questions or bring up points for discussion.
Hey Richard, what are you doing?